AI agent error handling got real for one of my teams when a coding loop burned through 12 model calls fixing the same test failure. The first repair renamed a function, the second renamed it back, then it edited imports, reformatted files, and confidently reran the same broken test. The problem was not effort. The problem was that every failure was treated as try harder. The verifier knew the error, missing product requirement, not bad syntax, but our leap had only one recovery path: retry. That is how agents turn small uncertainty into expensive noise. Blind retrying works when the failure is actually transient, a timeout, a rate limit, a flaky dependency. It is weak at everywhere else. If the agent lacked a fact, another generation does not magically add that fact. If the plan was wrong, patching one paragraph keeps the wrong strategy alive. If the agent lacks authority, like permission to delete data or approve money, retrying is not just wasteful, it is a control failure. Naive loops also blend budgets together. 3 network retries and 3 content repairs are not the same risk. When every failure shares one counter, you either stop too early on recoverable issues or keep spending after the loop is already stuck. The pattern is simple. Before any retry, classify the failure and route it. I use 5 classes as a default starting point. Transient means the environment failed, so back off and retry the same operation. Do not regenerate the work. Correctable means one part is wrong, so send a repair packet and modify only that part. Knowledge means the loop is missing facts, so return to discovery. Planning means the known facts are enough, but the strategy is bad, so preserve facts and replace the plan. Authority means the agent is not allowed to proceed, so stop immediately and escalate. The point is not taxonomy for its own sake. The point is different recovery behavior. Mechanically, make your verifier return a routing contract, not just pass or fail. The fields I want are failure class, evidence, recommended action, and return to phase. Then bind each class to a budget. For example, transient retries equals 3, repair attempts equals 3, replans equals 1, and rediscovery equals 2. Transient route, exponential backoff, same input, same artifact. Correctable route, create a repair packet containing the failed check, evidence, current artifact, and a narrow edit instruction. Knowledge route, go back to discovery and collect missing facts. Planning route, keep the evidence store, throw away the strategy. Authority route, stop and notify a human or policy system. Also store duplicate failure fingerprints, error type, target, and failed check. Same fingerprint twice after similar fixes, forces replan or escalation. Take a research loop writing a short market brief. The verifier checks each claim against collected sources and flags this sentence. Revenue grew 20% last quarter. The citation does not support it. A naive loop asks the writer to try again. It may produce a smoother unsupported claim. With routing, the verifier labels this as knowledge if no source contains the number. Recommended action, return to phase equals discovery. The agent searches approved sources, records the actual revenue figure, and updates the evidence store. Now the repair step edits only the failed sentence and citation. If the number was present but copied incorrectly, that would be correctable instead. Same output area, different route, different budget, much less wandering. This pattern is not magic. The main failure is a sloppy verifier that guesses a class without evidence. If it says planning failure but cannot point to the contradiction, you will replan for no reason. Another failure is vague repair packets. Fix the document is not a repair packet. Replace this unsupported claim is. Budgets also need to be separate and visible. If product pressure turns every limit into unlimited, the routing table becomes decoration. Fingerprints can be too broad as well. If every database error shares one fingerprint, you escalate harmless flakiness. If fingerprints are too narrow, you miss repeats. Tune them from real traces, not theory. This sits right between verification and orchestration. Verification tells you what failed. Failure routing decides where control goes next. State matters because knowledge failures and should update an evidence store, not disappear into chat history. Budgets matter because a loop without counters is not a loop, it is an appetite. Stop conditions matter because authority failures must not be negotiated by the agent. In this foundations tier, we are building the habits that later scale to multiple agents. Explicit phases, explicit contracts, and explicit exits. Opinionated take. If your agent can retry, it must also be able to explain why this retry is the right kind. Here is the 10-minute exercise. Open logs from one automation you already run. Take the last 10 failures, even if they are messy. For each one, assign one of the 5 classes: transient, correctable, knowledge, planning, or authority. Then write the route you wish the loop had taken. Back off retry, narrow repair, rediscovery, replan, or stop and escalate. Add a budget number next to each route. Finally, define a fingerprint using 3 fields: error type, target artifact, and failed check. You do not need a new framework. A small routing table beside your verifier is enough to expose waste fast. 3 beats to keep. First, blind retries are only correct for a small slice of failures, mostly transient ones. Second, make the verifier return failure class, evidence, recommended action, and return to phase, so the loop has a real routing decision. Third, separate the budgets. Transient retries, repair attempts, replans, and rediscovery are different controls. Add duplicate failure fingerprints, so the same mistake twice forces replan or escalation instead of another hopeful edit. This is loop engineering, reliable agent loops with state, verification, budgets, guardrails, and stop conditions. New loop engineering episode daily on this channel. Build loops that finish, verify, and stop.